I really wanted you to get to do, is just to play around and develop examples. When people come in with classes with examples, I'll be very honest, they either looked it up or they spent a lot of time developing it. So developing examples is it's one of the parts of what we do. And professional mathematicians, that's how they derive their theorems. They play around a lot, and they get an idea or a sense that something they're playing around with is true. That becomes a conjecture. Like in number 2, you said that the answer was D. Now it's a conjecture. And then once you believe it enough, you go and try to prove it. So those are the steps in research mathematics. So let's move on. Can you see? You're welcome to sit where you want to sit. So if you want to move back, it's fine. So I'm going to prove this theorem. One of the things walking around in the classroom, and also somebody had turned in a different kind of proof for one of the problems I presented last week, is what constitutes a proof and what does not constitute a proof. So this idea that someone in a class that's not your class could read what you've written and totally get it without asking a question is a good yardstick for figuring out whether you've written enough detail and made it clear. It is an art. I actually have a Bachelor of Arts in mathematics. So mathematics and philosophy are very close to each other, and it's creative and it's an art. I hate when people say, I'm a math person because I'm not that creative, or, oh yeah, creative people go to this field and not that field. Like, I think I'm pretty creative when I come up with these solutions or develop these examples of conjectures and come up with things that are beautiful. There's a beauty in it. All right, so let's go for this. For the entire semester, I'm going to do the scratch work. There's a difference between the scratch work, which I come around and see at your desk, and the actual proof. And I'll separate the two. I'll show you the scratch work, because I don't want to show you complete proof without showing the thought process of how I got there. But then I'll always show you the clean proof of what it should look like on a turned-in homework in someone else's class that wants you to do that. Okay, so the first step is always to write down what you know. So I know that D is a positive integer. I just scrape off the words between the if and the then. And that has to come down. And sometimes people are really resistant on writing that down. And I can't figure out why, because I'm really writing down the pathway for you to figure out how to write these proofs. That's the first step. There's nothing really to expand. D is a positive integer. I have some examples of positive integers in my mind. That's pretty much it. Write down what you have to show. Well, I believe that D is the greatest common divisor of these two, D and ND. Well, I have to expand that. That actually has definitions associated with it. So I go look up the definition and write down what it is I have to show step by step. Line it out. Well, the first thing I have to show, if I believe D is the common divisor, is that checkbox 1, that D is a common divisor, that D divided both the first number and the second number from the definition, just ripped off. And second, I have to show if there's any other common divisor, that common divisor is going to be smaller than my D. So those are the two checkbox criteria that I have to show. You might feel that I'm writing a lot. I'm actually a minimalist in my department. I write less than most people in my department. So I'm not actually writing a lot. I think someone in our class actually said they like math because it's not a writing field. It is, I write so much. I write so much, not just my proofs. I write grants. If you're going into teaching field, you'll also write grants. You'll write grants to get stuff for your classroom. So I write probably more than they do over in the other departments. 98% of the funding that we get on the campus comes from science and math. Grantsmanship. It's all about writing. Where's the aww? That's how they feel over in the humanities when you show them something with math. I thought you said there'd be no math. We're all connected in some way or the other. The first statement, I think, is obvious because I can use the definition of divide and come up with the S and the T, the multiple, right? The first number divides D because there's this 1, D times 1 is D, so I got that one. And N divides D because I can rotate the D and N around, and you know how I have the something divides something else if I have an S and a T? Well, there's my S and T. I'm done. So I just, for my scratch work, if you're not following me, just nodding your head because you're starting to fall asleep, that's why I have this, I've highlighted the 1 and the N there. So it comes from the definition. And then part 2 is always hard. Part 2 is the harder one. So to prove 2, I'm going to assume that I have some other common divisor, C, and I've got to show that C is smaller than D. Everybody's different how they write proofs. For me, I have severe attention problems. So I have to write down to myself, I have to show, because 2 seconds later I forget what I was doing. So for that's me. I have to write it down that this is what I'm supposed to do. This part here, whenever I say assume, that pops up as no. So I've just assumed something's a common divisor. So I can use, that's a nugget I can use. So I can take that expanded part there after I said assume. So you can do the same thing in advanced calculus. Assume x is the limit of blah. Then you can use all the things that you know about x being in the limit. You're allowed to use that in your no. So I take that expanded circle part and I expand it out. What does it mean for it to be a common divisor? It means C divides D means there exists an integer s such that D is equal to CS. And C divides ND means that there exists an integer t such that ND is C times t. And I boxed those off on purpose. I accidentally boxed them off because it's a habit. But I box things off that I can get my hands to work with. Words I can't get my hands to work with. But equations I can start working with those. So I boxed them off because they're important to me. That's good stuff. That's good usable stuff. So what do I got to use? I got D is C times S. And I think this does it. Just I'm staring at that and I think I'm done. Because if D can be broke up into 2 pieces, multiplied at C and S, then C and S have to be less or equal to D. I'm not working with fractions. I'm working with just positive integers. So if I have 2 positive integers that multiply up to be a 3rd positive integer, each one of those positive integers has to be smaller than or equal to what my final product, right? Oh, circle part disappeared, but that's what I needed to show. Okay, that's scratch work. I think there's supposed to be a C is less or equal to D there. So that circle part is what I needed to show in the last part. So what does the clean part look like when I write this up as a clean proof? Totally different. You don't see any of the sweat. It's supposed to be beautiful. It's supposed to be written in an artsy way. Everybody's got their style. So I start out with let D be a positive integer and let N be a natural number, positive integer. I claim that D is the greatest common divisor of, I need an opening statement, somewhere to let my reader know what I'm going to do. To see this, I'm first observe that D is D times 1 and ND is D times N, all from my scratch work. By definition of divisible, D and ND can be expressed as multiples of D. In case my reader forgot the definition of divisible, D divides D and D divides ND. So in one sentence I have the reader with me. So it's all about the reader, nothing about you. It's not about you, it's about who's reading it. So the reader's walking with me. They're like, okay, they got checkbox 1. And now the reader has attention problems. They're off in some other land. So bring them back. Now we're going to claim that D is the greatest of all divisors. Everybody's got their style. That was how I decided to write it. I'm going to show it's the biggest one. To see this, assume that there's another common divisor. C divides D by definition a common divisor. But then C is less or equal to D. Because anything that divides something else has to be smaller than it. This proves that D is the greatest common divisor, and I underlined it. You're allowed to do anything you want. You're allowed to use colors, you're allowed to underline, you're allowed to italicize, you're allowed to cap something. It's your style, however you want to convey it clearly as possible. Okay, questions? Clear as a bell when you write it up, right? Think about how when you look in the book or you see a professor present a proof, you're looking at just that polished version. Not what led up to that polished version, not the puzzling around and messing around or thinking, oh, this approach didn't work, that approach worked. You just see the final outcome. And it should be beautiful.